Hi everybody. So in this last video, what we're going to analyze is how to calculate the three different types of power that exist in the circuit that we have constructed here. So I have my apparent power, I have my real power, and I have my quadrature power. So the values that I'm going to use is this 7.68 amps at its appropriate angle and the 120 volts at its appropriate angle. And the important thing to remember and to identify is when am I using the angle at what point. Okay, so when I'm using for my apparent power, because I want all of those values to be intact, so I want the voltage at its appropriate vector multiplied by the current at its appropriate vector, okay, then I will get my 120 volts at 0 degrees multiplied by my current of 7.68 amps at 39.8 degrees. And the reason we want this to be a positive value is because I know with this inductive circuit, how industry deems what the power is whether I'm consuming or whether I am giving back. So with inductive, because those are consuming VARs, we want those to be positive. So real power is going to be a positive value. Anything inductive, anything that I'm consuming, I want to be a positive value. So I want this to end up being a positive value because I know it's an inductive circuit. And that's indeed what I end up with. I end up with a 921 VA at 39.8 degrees. That's a positive VA, therefore it's a positive angle, and I'm consuming that apparent power. So the same is true for watts. And where we place this angle is important with these different components. I'm going to use my electromotive force times my current, kind of switch my convention, I'll go back to this, dot product, and times I times cos theta. This is where my angle is represented for when I'm calculating my true power. So I can just leave it as 120 volts multiplied by my 7.6 amps times cos theta, and I'm going to end up with about 708 watts. A positive value, absolutely, because we are consuming those watts. And that's how they determined it, whether it should be positive or negative. They said, well, watts are always positive. They're an absolute value. So my watts are always positive. Those are being consumed. So anything else, any other type of power that is being consumed or taking up a capacity should be positive as well. So then when I do my quadrature power, I'm going to use that same method. I'm going to do E times I, and I need to know the vertical component, or what is out of phase, okay, from that angle, from my reference. So this will be 120 volts times 7.68 amps times sine theta. Sorry, we know what theta is in both of these. I'm going to go back and rewrite this. I kind of jumped ahead. So this cos theta, sorry, should be 39.8 degrees. Sine theta should be 39.8 degrees. We know what theta is. I don't have to write theta. Apologize for that previous. So now when I look at what my quadrature power is, it is 588 VARs, or VAR. So it's a positive value because it is being consumed. It is taking up capacity on my grid, on my circuit. So this is how I'm going to utilize, with the polar method, the magnitude and the angles to come up with their appropriate values. So I hope this has helped. I look forward to seeing you in the next one.